Hi, welcome back to LeetCode. So in this video, I am going to discuss LeetCode problem 3566. Partition array into two equal product subsets. So you are given an integer array nums containing distinct positive integer and integer target. Okay, so you'll have one array and another we actually have one variable as target. So we will determine if you can partition nums into two non-empty disjoint subsets. Two non-empty disjoint subsets with each element belong to exactly one subset, such that the product of the elements in each subset is equal to target. So you have to return true if such a partition exists and return false otherwise. So that means, suppose for this example one, we actually have an array of 3 1 6 8 4 and target is 24. So we have to partition actually create two subset. One is says this subset 1, another is this is subset 2, s1 and s2. We have to find out some like any partition is possible or not, such that the number present in this subset 1, suppose x1 x2, and so if the product of this x1 into x2 will be equal to target. Okay, similarly for suppose here actually x3 and x4 present in the subset 2. So similarly, x3 into x4, the multiplication of all the number present in this subset will be equal to also target. So we have to find out that such partition is possible or not. So suppose for this example 3 1 6 8 4. So what actually I can do? 1 minute. So suppose I have taken 3 8 in the subset 1, and in the subset 2 I actually have other elements, that is one remaining element 1 6 4. So for this, what is the product of all the number present in this subset? This is 3 into 8 24. That is equal to target. Yes, that is equal to target. Similarly for the subset 2, the product is 1 into 6 into 4 24. That is equal to also target. Correct. So I can say that at least one such partition exists. So this is return true. Output will be true. Got it? So that's why for the example 1, the output is true. Similarly for the next example 2537, the target is 15. So what actually I have to do? First of all, generate one subset whose product is 15. Similarly for the remaining number, the product will be similarly for also that have to be 15. So what actually I can actually observe here? So if I know what is the total product, it means 2 into 5 into 3 into 7. This is the total product of all the numbers from the input array. Now I know that one subset, the product has to be 15, and similarly for other subset also this has to be 15. So when actually I can actually generate, like maybe a possible answer actually exists, maybe, but not sure. But when actually it is not possible to generate an answer, like when suppose our here actually product is suppose this is actually 48. Okay, 48 total product, suppose random. This is take another example that will be better. So x1 into x2 into x3. So product is suppose 48, and our target is x. Okay, and suppose this is actually better to take as in y. So this is actually total product is y and target is x. So what actually I can actually generate, because this actually is like all the numbers have to be exist in subset 1 or in subset 2, correct? So total product x into x has to be y. This has to be equal to y, right? Clear? Because this is subset 1, this has to be subset 2. I know that the product of the subset 1 should be also x, and product of the subset 2 also has to be x. But all the number, if I multiply this has to be also equal to y, correct? So if y by x not equal to x, then actually we can't actually generate such kind of actually subset, correct? There is no such no possible answer exists. Suppose y is 48 and x is suppose 25. So 25 into 25, I'll get 625. So is this equal to 48? No, because I know that all the product of all the numbers is equal to 48, but I need two subset whose each product is equal to 25 25. So total product will be 25 and 25. This is 625. So this is not equal. So I can't actually generate any answer. Clear? Why actually I can't generate answer? Now this is next possible that this is sure. But next what I have to do? Maybe I can actually get any answer, valid answer. So what actually I can do? So I can actually generate all possible subset. Generate all subset. So that means I know what actually I can. First of all, I will find the total product. Okay, that means this is ultimately y. Now what I have to do? I will generate one subset. Suppose subset 1. I am generating the different different combination in set 1. Okay. Next, ultimately what will be the product of S2? That will be y by S1. Clear? What is the product of the S1 in the subset 1? If I divide y by S1, that will be I will get the product of the subset 2. The remaining number present will be present in the subset 2. So one number n will be present in subset 1 or subset 2. If it is not present in subset 1, normally it will be present in the subset 2 or either, correct? Either subset 1 or in subset 2. So if I suppose I know the what is the product of the subset 1. So what is the product of the subset 2? I will actually I will get from total product by subset 1, product of the subset 1, that will be the product of the subset 2. Clear? So first of all, find the total product. Clear? Now what to do? I will generate all possible subset 1. So if I generate all possible subset 1, so I will know the product of subset 1. Correct? So I'll check that if the product of the subset 1 is equal to target. Okay, so it is equal to target. So automatically the product of subset 2 will be equal to total product by target, and that should be equal to target. So do I need to check both the case, like product of S1 is equal to target or not, or also the remaining the product of subset 2 is equal to target or not? Would you need to check this product of subset 2? Why? Because I have already ensured that I have one answer, target into target equal to total product. I have already ensured in here actually in this case I have already ensured that or actually I have the condition I have written that it should be equal to this target x into x should be equal to y, means target into target should be equal to total product. Clear? If it is not equal, then I can't even generate any answer. So here actually I already know the product of the subset 1. So I will check that. If I check that is this equal to target, that means automatically the product of subset 2 will be a target. Product of subset 2 will be also the target, equal to target. Got it? How to ensure that? Clear? So now the main the main algorithm what I have to do, main thing, that is to generate all possible subset. So how can we generate all possible subset? So what actually we can do that non-empty subset. So there should be at least one element in each subset. So suppose you actually have x, y, z. So if I do one thing, this is 0, 1, 2. So if I actually take the this is actually straightforward solution to generate all possible subset. You can check it also. One thing actually I can just revising the algorithm. Like we actually have the index. Like this is for the first number, second number, third number. Index is 0, 1, 2. Suppose we actually have 3. So I actually have value 3. So in the binary representation, this is what 0, 1, 0. That means this is if this current bit is still set means 1. That means this number is present in the current subset. If it is 0, that means not present. It is present, else it is not present in the current subset. So if it is 3, that means 0, 1, 1. This is a binary representation. Now you can see that this bit actually set, that means x is present. This bit actually set, this is 0th bit, this is first bit, this is second bit. 0th bit is set, that means x number will be present in this subset. So x into, similarly for this first bit, actually first index is set, first bit, so this is actually the ultimately y. So x into y, this z means the second bit actually set, no, this is 0, so this is not present. So ultimately what is the product of this subset? X into y. Clear? This is clear. Now I have to check that x into y is equal to target or not. If it is target, so that means this is our answer, so I'll return from here. Else I have to go to the next next possible subset. So what actually the number actually I can generate? Suppose there are 3 numbers, so how many actually possible subset actually is possible? This is 0, 1, 2, 3, means this is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 1, 0, then 1, 1, 1. That means actually no number actually select, because no bit actually as 1. Similarly, so there is no number, so product will be at 1. Similarly for this is only this number actually selected present in the subset, so this is means x will be only present. Here it is only y is present. Here actually x into y. Here it is only z is present. Here actually z into x is present. Here actually z into y. Here actually z into x into y. So you can just see here that I can actually generate all possible subset. Here actually no number is present in the current subset. This is that means here actually empty. Similarly for here actually only one number. Here is also one number y. Here actually it is 2 number x and y. Here actually only one number. Here is a 2 number. Here is also 2 number. Here is all the 3 numbers is present in the subset. It is possible. So you can just see that what is the value it is in the numerical value. This is actually 0. This is 1. This is 2. This is 3. This is 4, 5, 6, 7. So that means if there are 3 numbers, so this is actually 2 to the power 3. This is 8 minus 1. So number will start from 0 to 7. Clear? How can you generate all the possible subset? Okay, now what have to do? So it can actually take this and this number, this 0 and 7. No, why? 0 means there is no number present in the current subset, so this is not possible, because our subset should be non-empty. At least one number should be present in the current subset, so this is not possible. Similarly for here actually that what actually it indicates that all the numbers are present in the current subset. Is this possible? Suppose in the subset 1 I have taken all the elements, then what will be the number present in the subset 2? That will be empty, so this is not possible. So what is I can take only 1 to 6 only. Clear? So in this I will generate all the possible subset, and I will take the multiplication, that what basically set. If it is set, that means the number is present in the current subset, I will multiply that. So ultimately after checking all the bits, I will know what is the current product. So if it is equal to target, so this is one possible answer, I will return true. Clear? After checking all the possible subset, if I don't find any answer, if I have not find any answer, so that time I have to return -1. Clear? So this is clear. What is the steps? First of all, the base case is that I have to check that the target actually possible or not. So whatever the total product, if I multiply the two target into target, because there are two subset S1 into S2, so if it is equal to total product or not. It is not total product, then actually I can't actually generate any partition, so that's why return false. If it is not, if I can possible answer not, I have to check that I have to generate all possible subset. So if I generate only one subset, automatically I will get the subset 2 also. S1, if I generate all the possible subset 1, automatically I will generate the corresponding subset 2. So if I check the subset 1 actually the product of the subset 1 number present in subset 1 is equal to target or not, then I will get this is one possible answer, I will return true. After checking, I don't need to check the subset 2. I have already explained why, because I have already ensured that I will get two same target two subset of the same value. So if one subset is already target, then another will be always the total product by target. So that should be equal to target. I've already ensured that. How actually ensure? If I actually multiply with target in the both side, I'll get total product equal to target into target. Got it? Math, just math, simple math. So after that, I actually use the bitmasking here to check all the possible to generate all the possible subset. So I have already ensured why actually I have not used this 0 and 2 to the power the number of 2 to the power n minus 1. So because 2 to the power 1 n minus 1 indicates that I have taken all the elements in the current subset. So this is not possible because the other subset will be then empty. Clear? And 0 means there is no number element is present in the current subset. So this is not possible. So that's why I can take only 1 to 2 to the power n minus 2. Clear? Then similar way I actually take the product of the current subset. So now go to the code, then it will be more easy to understand. So first of all, find the total product. So total product of the numbers present in the input array. So I'll just iterating all the numbers present in the nums array and just storing into the total product. Okay. So I have to check that if total product by target equal to not equal to target, that means this is not not possible to generate two equal subset of equal products. So x into x should be equal to y. So that's why if y by x not equal to x, that means this is not possible. So that's why I will return false. If it is not possible to divisible also, suppose we actually have 24 and we actually have 37. So can actually generate two possible? No, because is it possible that 12 into 12, this is 144. But suppose we actually have 145 total product. But actually, if I divide this 145 by 12, I will get 12. So both are actually equal, but this is not equal to 145. So that's why I'll check that if it is not equal to the modulo of 145 modulo of 12 not equal to 0, that means this is not completely divisible. We actually have some modulo that is not possible. So that's why I return false from here. Got it? Else I have to generate all the possible subset of the subset, only one subset. Then we'll check that this is the product of this is equal to target or not. So that's why our value will be starting from what? So set equal to 1, the value can be from 1 and less than 2 to the power n minus 1. Got it? And set plus plus. So if I have to take the current product, so initially the current product will be 1 and I am iterating all the numbers. So this will be 0 to n minus 1. So I'll check that current bit means the 0th bit, first bit, second bit, like this. I will check all the bits. So if this the current value, whatever the value actually I have, and the current bit y left set of j, that means jth bit is set or not. If it is equal to order, so I will enter this if block and I will take the current nums of j and multiply this with the current product actually I have in the variable. But this indicates this that the current bit actually set, jth bit actually set. That means this jth number is present in the current subset. So I will multiply this with the current product. Correct? After iterating all the numbers, I actually have the current product of the current subset in the current p variable. So I'll check that if the value of the current product or the current subset is equal to target, that means return true. After this for loop, I'll actually generate all the possible subset of subset 1 and subset 2 corresponding, both are actually equal. So after checking all of this, if I don't find any answer, delete partition. So I've written false ultimately. So return false here from here. Got it? This is clear. I have shared this code in the description. If any suggestion, any doubt, you will comment on that. And if you're not yet subscribed, please subscribe the channel. Thank you.